Hello, today we are going to see on types of a relation. So let's assume that R be a relation on a set A. So we meant by R is reflexive if for every A in A, the order pair A is an element of R. So for example, if R is the set containing 1, 2, 3, then we can have a reflexive relation which is given by, let's say, 1 2 1 1 2 2 3 3. So this is one relation, and the other we can have this 1 1 2 2 2 3, I mean 3 3, let's say, and you can have 1 2, and you can have 2. So this is another example of a reflexive relation. So we meant by a relation is symmetric if for every A and B in A, if we say that the order pair AB is in R, then the reciprocal or the inverse BA should be in the relation A. So you can have, like, by assuming the set A is containing 1 to 3, then we have a symmetric relation R, which is given by, let's say, 1 2. Then if there is 1 2, then to be asymmetric there should be 2 1, and let's say 1 3. Then to be a reflexive, I mean symmetric, then there should be what, 3 1 should be there. So this is one example of symmetric relation. So we say a relation is transitive then for a triple elements in A, if we say that AB and BC is in R. So remember that the second element for the first order pair should be the first element for the second order pair. So then the order pair AC is element of R, then we say the relation is transitive. So for example, I can have R, which is given by, let's say, 1 2, and so let's say 2 3. Then to be the relation is transitive, then as you see here, there is 1 2 and there is 2 3 here. So to be a relation is transitive, there must be these are should contain 1 3. So this is one example of a transitive relation. So you can have more, you can try by your own self. So we say a relation is irreflexive, that means for every elements in A, the order pair AA is not a member of R. So that means it's like the negation of reflexive relation. So that means if R contains at least one elements, that at least one order pair having equal elements, then we say the relation is not irreflexive. For example, you can take this one 1 2, then 1, let's say 1 1, and 2 3. So this is not irreflexive. Why? It's because of this one. So it says that for every A in A, this one, the order pair A is not a member of R. So but this relation, as you see, it contains this one. So because of this, we say this is not irreflexive, neither irreflexive nor reflexive. It's not reflexive again. But you can have this one, this relation, let's say 1 2 2 3. So this is an example of irreflexive relation. So the last one is asymmetric relation. So asymmetric relation, we say a relation is asymmetric for every elements A and B in A. We say AB, if we have AB is an element of R, then BA, the order pair BA, is not a member of R. So but if you remember the definition of symmetric, we say AB is in R, then to be symmetric BA should be in R. But for asymmetric case, BA is not a member of R. So for example, you can take R, which is element of 1 2, let's say 2 2. So this is what, this is not asymmetric, because what, if you take this one 1 2, there is 1 2, or I mean this is asymmetric, there is 1 2, so the reciprocal 2 1 is not the member. But when you see this is 2 2, 2 2 is the element of R, and the reciprocal again is 2 2, so we say this is not asymmetric. This is an asymmetric relation. This is not an asymmetric relation. Also, this is not what, this is not asymmetric. It's neither asymmetric nor what, nor symmetric. This is not we say this is not asymmetric because 2 2 is a member of R, but we say this is not symmetric because what, there is 1 2, but there is no 2 1. 2 1 is not a member of R. So this is the difference between asymmetric and symmetric. Then you can see here also, this is again, this is not reflexive. Again, this is not what, not reflexive. Why? Because it doesn't contain 2 2 and 3 3. It only contains 1 1. So this is the difference. Thank you for watching.